Today I'm going to talk about the future of privacy and proof of innocence. So, what is proof of innocence? Proof of innocence is a tool we built on top of Tornado Cash. So, let's remember how Tornado Cash works. It is basically a Merkle tree where every deposit is added, and whenever you're withdrawing, you provide a zero-knowledge proof that you are inside that Merkle tree, and you only reveal your nullifier, so there's no linkage. So what proof of innocence does is, so these deposits also includes deposits from bad actors, right? So with proof of innocence, you can remove that bad actors, and you can also prove to an association set. So with association sets, you can you'll get more small association sets, so more like less anonymous, less privacy, but that's okay. You're not mixed with bad actors, right? So one observation is exclusion proofs and membership proofs are same, because these deposits are a finite set. So if you're proving to an association set, it's exactly the same as proving to exclusion set. So selecting this association set is really hard, because there can be thousands of deposits. So there will be association set providers where they listen to every deposit and provide you with a list. This can be like AI or like chain analysis company, etc. So we built proof of innocence on top of Tornado Cash. You can try out the demo. And there's also privacy pools built by Amin, which is a different privacy pool which also have proof of innocence capabilities. And then also we got grants from Moloch DAO to implement proof of innocence on top of Tornado Nova. And we also got grants from Railgun to implement their protocol as well. So implementing proof of innocence on top of Tornado Nova is not trivial. So let's remember how Tornado Nova works. There's this join split transaction where it spends two inputs and reveals two UTXOs. These UTXOs are then added to a Merkle tree. And there's this also public amount, which is a deposit if it's a positive, and it's a withdrawal if it's a negative. So let's say you haven't done any shielded transaction and you're just depositing arbitrary amounts and withdrawing arbitrary amounts. So this is how your transaction graph looks like. You just deposit and withdraw. And if you do a shielded transaction, you send to a different public key and only they can spend it. So this is how transaction graphs looks like. So in the eyes of this yellow account, these gray UTXOs, they don't know which are they. So they only know they received 4 coins. So if we do like proof of innocence with this, they will receive a proof of innocence with an association set for that time. So if the yellow user wants to provide a proof of innocence at the end, they will need to use that proof, but they have a different association set. Remember that these association sets are incrementally updating. So at that time, yellow is withdrawing that money. The current and updated association set will be different. So what we need Merkle subset proofs. A Merkle subset proof is a proving that these two Merkle trees are a subset of this at the final Merkle tree. So this is not trivial. We implemented it with like Nova folding scheme where we add basically a leaf at every folding. And we also did some optimizations to add a Merkle subtree. But at the end, we got like optimized log of n complexity, folding complexity. It takes like 4 seconds and it's really fast. But then, do we really need this Merkle subset math? Like, association set providers can also add the output UTXOs to their list. So we conclude there's like 3 constructions of proof of innocence: type 1, type 2, and type 3, just like ZK EVMs, right? Type 1 is using proof carrying data, which is the most advanced proof of innocence basically, where whenever you do a shielded transaction, you also do like subset math, subset proofs, and at the end, you only provide a public proof of innocence when you're withdrawing. Type 2 is you only provide a proof of innocence when you're withdrawing and making a shielded transaction, meaning that if you haven't done any shielded transaction, at the end, you can fold all your transaction instantly and have a proof of innocence. And type 3 is whenever you provide a public proof of innocence at every transaction, whenever you do a like deposit, withdraw, or shielded transaction, or a simple joining transaction, you provide a proof of innocence. So at type 3, association set providers work are much because like they are verifying every public proof. And type 1, they're only verifying withdrawals. So we implemented to type 2 with novel folding scheme, where at every step you are folding your membership proof, and at the end, when you're withdrawing, you will have a single membership proof. We have 2 issues right now. So current novel folding implementation is not zero knowledge, so it's not production ready yet. And so proof generation slows down a lot when we convert it to WebAssembly. I don't know, like 1 minute, it takes 1 minute on my M1 Mac. So we tried PROGCRYPTO as well to get the type 1 proof of innocence. But that current Poseidon hash implementation was taking 60 seconds. I then tried to optimize it with like optimizing non-native arithmetic and got it to 6 seconds. But however, whenever we converted to WebAssembly, it took 10 minutes. There's also more research needed for optimized proof of innocence. Like maybe we can use polynomial commitment schemes instead of Merkle trees. Maybe using some new folding scheme where you don't have to compress the final proof and you can just make it like blinding and send it to another someone else or your shielded transaction. So thank you for listening. I will be around for discussing it more. There's also Proof of Innocence Builders Chat Telegram group, and you can ask me for an invite or DM me. Thank you very much.